Hello everyone, welcome back to my YouTube channel Chemistry Pocket. I am your chemistry mentor Sreelatha. In this video, I am going to give tricks to find standard EMF of a Voltaic cell with problems from electrochemistry of class 12. Now let us start the class. So this is the question. Calculate the EMF of a cell. The cell representation is given and given the electrode potentials or so E0 magnesium is given as minus 2.37 volts and E0 silver is given as in 0.8 volts. So to calculate the standard EMF of a cell, so first we need to write the formula. Okay. So what's the formula is there? E0 cell equals to E0 cathode minus E0 anode. So E0 cell equals to E0 cathode minus E0 anode. This is a formula what we are going to use to calculate the standard EMF of a Voltaic cell or galvanic cell. So that means here the two values are given. We have to substitute those values in this one. That's it. We will get the answer. But what is the main important point is we have to identify what is an cathode value and what is an anode value. That means here two metal ions are there. So one is oxidized and another one is reduced. How we can know that one means? So with the loss of electrons and with the gain of electrons or with the decreasing of an oxygen state or with increasing of an oxygen state, we can identify which metal is oxidized and which metal is reduced. But keep all those things aside and use the trick what I am going to give to solve this problem. So by using my trick, definitely you can solve this question in fraction of seconds. Okay. So to identify that, I am going to give the trick as ABC trick. What is the trick I am going to give? ABC trick. In this ABC trick, so what is A? A means anode and B means bridge. It is nothing but salt bridge and C means cathode. Just remember this trick, ABC trick. To solve, that means or to find the standard EMF of a Voltaic cell, we should remember the trick as ABC trick. A is nothing but anode, B is nothing but bridge and C is nothing but cathode. That means in the question already they given the cell representation. So in this cell representation, this left hand side part represents anode. Left hand side part represents anode and the right hand side represents cathode. And this double line represents bridge. Okay. So if you identify this, you can easily substitute those values in the formula and you can find the answer. So A, B, C trick. Okay. Now what is anode part here? Magnesium. What is the magnesium value here? Minus 2.37. And what is in cathode here? Silver. What is in silver value? 0.8. Substitute those values in this formula. So E0 cell is equals to E cathode. E cathode is nothing but silver. Silver value is 0.8 volts. Minus. What is an anode here? Magnesium. So magnesium value is minus 2.37 minus 2.37 volts. It is nothing but 0.8 volts plus 2.37 volts. Minus into minus plus. Just add these two values and we will get the answer. 0.8 into 0.8 plus 2.37. It is nothing but 3.17 volts. Now the answer is, what is the answer? 3.17 volts. See how easy it is by following this trick. So just remember A, B, C. A means anode and C means cathode and B means bridge. Okay. Now let's see the next question. Calculate the EMF of a cell and the cell reaction is given. Given the electrode potentials of copper and iron are 0.34 volts and 0.44 volts respectively. So to answer this question also, what is the formula we have to use? E0 cell equals to E0 cathode minus E0 anode. E0 cathode minus E0 anode. We have to use the same formula. But in this one, we have to identify cathode and anode. So already I told the first we should represent anode and the next part is in bridge. The double line will represent the bridge and the next one is in the right hand side part is called as cathode. Left hand side part is called as an anode and bridge is there and right hand side part is called as cathode. So cathode means E not copper value we should identify. So the values of copper and iron are given. So what is the value of copper? It is in 0.34 and the iron value is minus 0.44. So now identify E cathode. What is in cathode? Copper. What is in copper value? 0.34. 0.34 volts minus of 0.44 volts, because iron value is 0.44. It is nothing but 0.34 volts plus 0.44 volts. So 0.34 and 0.44, it is nothing but 0.74. 0.74 volts. Now the answer is 0.74 volts. Now let's see the one more question. Calculate the EMF of a cell if the reduction potentials of the cell are minus 0.76 volts and 0.34 volts. So observe this question. In last previous two questions, they given the cell representation. So from that cell representation, we are easily identified what is an anode and what is a cathode, and we substitute those values in the formula and we got the answer. But see this question. So in this question, there is no cell representation. Even though we have to identify what is an cathode and what is an anode to find the E naught of a cell. So for this one also I am going to give the trick. The trick is, so here two values are there. The greater value represents a cathode and the smaller value represents an anode. Greater value represents cathode and the smaller value represents anode. That means already you can easily identify what is a greater value, because it is a positive and it is a negative. So positive values are always greater than that of the negative values. So that's why this part is called, this value is called as a cathode and this value is an anode. Substitute the values and you can get the answer. So E naught cathode is 0.34 minus of minus 0.76 volts. Okay, it is nothing but 0.34 volts plus 0.76 volts. It is nothing but 0.34 and 0.76, 9. So 1.09 volts. Sorry, here 0 and 1.1 volts. 1.1 volts. So if the cell representation is given, so this is the way to find the E naught of a cell, and without cell representation we need to find the E naught of a cell means just consider the greater value as an cathode and the smaller value as an anode. Now let us see the next question. Now let us see the last question. So calculate the EMF of a cell if the reduction potentials of the cell are minus 0.74 volts and also minus 0.44 volts. For this one also we need to write the formula. Now write the formula. So E naught cell equals to E naught cathode minus E naught anode. So in between these two, that means without cell reaction, what I told, the greater value should represent the cathode and the lesser value should represent anode. So in these two, what is a greater value? Either 0.74 or 0.44. That means minus 0.74 or minus 0.44 means minus 0.44 is a greater value. So it should be considered as a cathode and minus 0.74 should be considered as an anode. So it is nothing but substitute those values in this one. Minus 0.44 volts minus of minus 0.74 volts. It is nothing but minus 0.44 volts plus 0.74 volts. So 0.74 and 0.4. That means subtract 0.44 from the 0.74. 0.3. It is nothing but what is the answer? 0.30 volts. E naught cell of a reaction is 0.30 volts. So now I gave one test yourself question. So calculate the EMF of a cell if the reduction potentials of the cell are given as, so E naught Zn is given and E naught copper is given. So after watching this video, you are able to do this question easily. Okay. Let us see the quick recap of this class. So trick to find the standard EMF of a cell. So to find the standard EMF of a cell, what is the main thing? We should remember the formula, that is E naught cell equals to E naught cathode minus E naught anode. Without knowing this formula, we can't do anything. E naught cell equals to E naught cathode minus E naught anode. And after knowing this formula, after writing this formula, we should identify anode and cathode by using a trick as ABC trick. The cell reaction can be represented in the same sequence A, B, C, anode, bridge and cathode. And identify the anode, E naught anode and E naught cathode values and substitute those values in the formula and you will get the answer. Okay. If the cell reaction is given, you need to follow this trick. If the cell reaction was not given, means just consider the greater value as a cathode and the smaller value as an anode, and we can solve the problem easily. Okay. Thanks for watching. If you really like my video, so please like, share and subscribe my YouTube channel Chemistry Pocket. Thank you.